Hello students, this is Ashish Vegadwa from the Electrical Department. Today we will learn Chopper Part 3 in the subject Power Electronics. Let's move to the content of this topic. In this topic we will learn Class C chopper. It is a 2-quadrant Type A chopper, and also we will learn Class D chopper. It is a 2-quadrant Class B chopper. Let's start with the Class C chopper. So Class C chopper is a combination of Class A chopper and Class B chopper, because Class A chopper is step down chopper, whereas Class B chopper is step up chopper. Hence the Class C chopper, it is a step down as well as step up chopper. It means it is a buck boost chopper. If the switch 1 and the freewheeling diode will operate together, it will operate as a type A chopper. Now, if the switch 2 and the diode D2 will operate together, it will operate as a type B chopper. It is a stepped up chopper and it will operate in second quadrant. When the switch 1 is on, the load current is positive. At that time, the output voltage will equal to the input voltage and the load receives the power from the source. If we turn off the switch 1, the energy stored in the inductor will flow from the load and it will dissipate. At the same time, the output voltage will be 0 as of this freewheeling diode D2 is connected across the load. Same time, the current will continuously flow in positive direction. If the switch 2 is triggered, the voltage E is forced current in opposite direction through the inductor and switch 2 will operate. Hence the output voltage will be 0. If we turn off the switch 2, same time the energy stored in the inductor drive current through the diode D1 and the supply output voltage is Vs and the input current become negative and the power will flow from the load to source. Average output voltage is positive because the presence of freewheeling diode. Average output current can take both positive and negative values. If the switch 1 and switch 2 shouldn't be turned on simultaneously, otherwise it will result in short circuit in the supply and it will damage the supply. Class C chopper can be used both for DC motor control and the regenerative braking of DC motor. Let's understand this part from the diagram. So as per the circuit diagram, it having two switch 1 and switch 2, and it having two diodes, that is D1 and D2, and it having one inductor and one source and one load. So it will operate in first quadrant and second quadrant. Now suppose if you have triggered the switch 1, the current will flow from the source to the switch 1, inductor and the load. So current will try to increase from the minimum to the maximum. Same time, if we turn off the switch 1, energy stored in this inductor will going to dissipate through this diode. Hence we will get output voltage will be 0 as of this diode D2 will be forward bias. So when the diode D2 will conduct, the output voltage will be 0. Current will try to decrease. Now if we turn on the switch 2 and if we operate the motor as a generator and we operate motor as a generator, then the current will flow from the load EMF to the inductor to the switch 2 and current will come back such that the switch will parallel to the load and the output voltage will be 0. Now same time this inductor is going to store energy, and if we turn off the switch 2, energy stored in this inductor and the load will going to discharge through this diode D1 such that it will going to charge to the supply. Thus way, when the switch 1 and diode D2 will turn on, it will operate in first quadrant. When the switch 2 and diode D1 will on, it will operate in second quadrant. Let's see type D chopper. It is operate in first quadrant and fourth quadrant. It also having two switch, that is switch 1 and switch 2. If both of the switch 1 and 2 will operate simultaneously, the output voltage is equal to the input voltage and the output current will flow from the supply to the load. If the switch 1 and switch 2 will turn off, the load current will continuously flow in the same direction through the load, through the diode D1 and diode D2, and energy stored in the inductor. The same time the output voltage V0 is equal to minus Vs, because sign of voltage will change across the load. Average load voltage is positive if chopper on time is more than off time, and average output voltage becomes negative if turn on time is less than turn off time. Hence the direction of current is always positive, but load voltage can be positive or negative. This is a circuit diagram of class D chopper. It having two switches, that is switch 1 and switch 2, and having two diodes, that is D1 and D2. When switch 1 and switch 2 will operate, it will operate in first quadrant. When diode D1 and D2 will operate, it will operate in the fourth quadrant. This is the waveform of class D chopper. Now, suppose we have triggered the switch 1 and switch 2. The current will flow from the supply to the switch 1 to the load, positive, negative, switch 2, and it will come back to the supply. Output voltage will be positive, will be equal to the input voltage, and the current will try to increase from 0 to maximum or minimum to maximum. Now if we turn off the switch 1 and switch 2, the same time during turn on time, load inductor is charged, so inductor is going to interchange their sign. So current will flow from the load to the diode D2 to the supply to the diode D1 and come back to the load. Then the sign of output voltage will be changed and direction of current will remain same. So we will get operation in fourth quadrant. Let's see question for assignment. Explain class C chopper and explain class D chopper in brief. Thank you.
If you like this video, please subscribe and like our YouTube channel LJP Electrical, and don't forget to click on the bell icon to get latest video update fast. If you like this video, please subscribe and like our YouTube channel LJP Electrical, and don't forget to click on the bell icon to get latest video update fast.